now as a grad student, which is fish color evolution, but also hopefully have some career development insights in here that may or may not help you guys, but hopefully you'll find something helpful from here today. Before I start, I'd like to go ahead and thank everyone that made it possible for me to be here today. So Future Frogmen, as Richard just introduced there, as well as the Beardsley Zoo, of course, and then my team here from Clemson University. So we are a lab that's just starting out there. So I sort of think of myself as one of these students who, yes, I'm in the grad program, but I had a little bit of a non-traditional journey. And I started out as a little kid up in Minnesota, so very cold and covered with snow. And then one year, the family took a trip down to Grand Cayman. And as you can see here, all of the really colorful fish that just immediately dazzled me, and I fell in love with that. It wasn't even the beach or anything like that. It was getting underwater, even though I couldn't use a snorkel at the time, and I get terribly seasick and all that. Somehow, I was hooked on that, and the color is something that really stood out to me. So I didn't know what I wanted to study in undergraduate, and I thought, oh, well, instead of just being a token, undecided first year, I'm just going to go for something. And I said, okay, marine biology. So I went to NC State University in North Carolina, and about halfway through, I thought, okay, I'm going to try to do an abroad program. Let's see what I can do here. And there was one that happened to be in this little field station called Forfar Field Station, and it's in Andros Island or the Bahamas. Obviously, it attracts more than just your biology students, right? But I was there mostly for the science. So basically, we shack up in these little huts outside, and we tried to come up with some sort of research project, and that was how I tried to learn the scientific method. Research is often said, okay, it's very hard and dirty work sometimes, or sometimes you're just at a computer, and I think one of the best ways to figure out if you really like it is just to volunteer your time and go try and see. And you'll either love it or hate it, or decide to explore some more. So that was sort of my first undergrad experience doing that. And then I took an internship at the Maritime Aquarium in Norwalk, which hopefully some of you have checked it out. It's so close by. It's such a great facility. I graduated and thought, okay, now what do I do? I'm kind of at this crossroads where a lot of people don't actually keep going to graduate school, and is it really worth it to pay to go back, you know? So what I ended up doing was taking a job with the Sea Turtle Camp, which is off of Topsail Island, North Carolina. And they essentially do a lot of work with sea turtle rehab with the Karen Beasley Sea Turtle Hospital. And you can see one of the green turtles right here. You may know most, in fact, I think all species of turtles are endangered, and they do have quite a bit of problems with marine plastic ingestion and differences in the currents that they essentially can't handle the temperature change and can be cold stunned. So I helped not only with the turtles, but also teaching other students how to care for the ocean and just about marine biology in general. So more of a teaching type position. It also happened to be that the students would stay for 2 weeks overnight. So that was kind of the fun part of being the counselor 24 hours a day. Whatever comes up falls on my desk, essentially. But I'm still very much in love with marine biology. So of course we need to fit the fishes. You may notice these are not completely all fishes, but a vast majority of them are. So we have an incredible diversity of these things. We have stuff that kind of crawls along the bottom. We have really flattened, really large fishes that live in open water. Really charismatic little reef species right there. We have fish over here like this mahi-mahi that is a part of commercial fisheries. So there's quite a diversity of fish out there. In fact, there are over 30,000 species, and they're about half of all vertebrate species with the backbone, are fishes. So excellent study system to study diversification of life. So some of the most notable things that they exhibit, right? There's very different ages. So this is a coelacanth. Yep, a very ancient lobe-finned fish that was fairly recently discovered as still living today. So it kind of hid out there for a while. We thought it was gone, and it popped back up. And then this cute little frogfish over here, which was the inspiration for the Future Frogmen logo. They have almost like little walking hands. And then deep sea stuff here with really, really, really large jaws and big teeth, but rather streamlined morphology, so really long and thin. And that essentially allows them to cruise those high pressure waters and then engulf prey when they happen to come upon it, because it's rather rare down there. And then we have crocodile fish, or crocodile ice fish. So these are fish actually in really freezing waters, and they actually have antifreeze in their system, so they do not actually freeze. And because of this glacial freezing and thawing, it's a really, really neat system to study how these things speciate, right? Because you're essentially resetting that clock every time you go through a big temperature shift. So I'm part of something that's looking into immunity in these ice fishes as part of a side project. But then my real thing that's close to my heart is the color. Right, this is parrotfish, and you can see very, very bright color on this fish, different colors, but also arranged in different patterns. You see some of it crossing the eye here, you have weird little spots back here. So this is what will probably be where my research starts to go toward. As far as color patterning in fishes, definitely one of the diversity axes for these guys. There's really, really prominent barring on this fish, as well as some things that are completely plain, like this Garibaldi. We have cryptic type patterns, so modeling on flounder and associated species. Weird stuff like polka dots. And then striking lines as well. So I thought, okay, this is what I want to do. I want to try to figure out why. Why are these things so colorful? Why do you get these stripes, and why are there these colors in this contrast and in that pattern on that size fish in this species? Not all at once, obviously. So there's several different hypothesized functions of these color patterns. Right? So sexual selection, as is a common one in cichlids up here, can drive that, and sometimes opposing the natural selection, right? Because species that, or individuals that are desirable or so-called colorful mates might actually be more conspicuous to predators, so you can have this weird trade-off between selection mechanisms. You can also get communication type stuff. Some fish actually have UV markings on their face, and it's thought that predators may not be able to see these UV, but they're covertly signaling to each other. And then you have some hypothesized anti-predator type colors, like this little humbug damselfish down here, and these are really high contrasting bars. And what you might notice is that if you squint a little bit, what really shows is these bars, right? You don't really see the outline of this fish, and that has been termed disruptive coloration, a type of disruptive coloration, where you're disrupting the body outline and essentially making it hard to know that you are actually a prey and a fish. So this is where my first chapter is kind of focusing on, is this disruptive coloration. Now to do this, we do everything in that fancy word phylogenetic framework, which what is that? It's essentially accounting for the relationships. So you can think of it as a genealogy, but with species. So here we have the so-called tree of life with all of the species branching off to it, but essentially this shows how closely things are related to each other. And what's really interesting is that some species on one part of the tree will look like some on the other piece of the tree, but they're not very closely related. And so you see some of these interesting patterns play out, that if you were to just categorize relatedness on how they look, you wouldn't necessarily get those genetic changes represented. So here is an actual tree. So this is the entire phylogeny of fishes. Not by me, by Roboski 18. So essentially, they would go sequence the information for these fish, and using differences in the DNA, come up with these relationships. And the way you read this is here is the beginning, and it radiates outward, and all of your different species are on the tips. So the closer the lines are together, and the closer that they diverge, the lines split, the more closely they're related by DNA. And the rainbow is just representing the families of the fish. So to do this, we use museums. Zoos, museums, aquariums are just an amazing resource for these sorts of things. And museum collections in particular are essentially a snapshot of time from when the organism was donated or collected. So we went to Smithsonian, grabbed a bunch of fish in alcohol. That was quite a fun summer. And yeah, there are quite a bit of species on here, close to 6,000 and just under 400 families represented. So an incredibly macro project. This took over 3 years, and actually a bunch of undergraduate students were really instrumental to helping with this. And we wanted to look at morphological type differences, so essentially how the fish is shaped, and we focused on body shape because fins don't preserve so well in alcohol for several hundred years. And we're measuring things like how wide is the fish at the widest point? How deep is the body? And what's standard length? And based on different systems, lizards or fish or whatever, you'll get these different standards of measurements. And for fish, you just measure up and toward the fleshy part where the tail ends, right? Because there's a lot of extra filaments and things you can get on the tail. So standard length. And then my personal project, which was the color pattern and the fish shape. So here I have a token butterfly fish, and I'm essentially scoring presence absence across this fish for up to 15 different traits, which is quite a bit, but you'd be surprised how you can get all this diversity of fish to fit into yes-no categories of color. This took several months of talking to people back and forth in meetings. So stuff like, does the head bar repeat? Is that eye concealed? Do we see other really high contrast markings on the body? And do we have different linear patterns? So there's body stripes and body bars like I showed you earlier. So I did that for about 500 species so far with the goal of eventually, hopefully, getting that 6,000. Yeah. So there were 68 species within the butterfly fishes that we could account for. And on the right, this is the stuff from the Smithsonian. So we pulled them out, put them in alcohol. We actually have a camera on a tripod that we take a photo of each one, so that not only can we get the measurements right there on site, we can also go back and look at this, the color of it, or we can landmark parts on the body, and that can give us a better idea of shape if we choose to do that. And then the other side, these over here, looking a little bit less rough, are from a database called Johnny Randall's Fish Photos. And these are freshly caught fish. So essentially, can I get my high contrast color pattern from these guys? And is it the same scoring as I would have done looking at these guys? Right? Because you kind of want to check for that consistency. It's odd. It's an odd concept to get color from already dead fish. So this is something I'm currently trying to prove to my but ultimately, I'd like to get broader, overarching questions in macroevolution. So why are some clades way more diverse than others? How does this factor into environmental change? You guys are interested in conservation pretty broadly, and there are lots of rapid scale changes going on right now. And I think it's quite informative to know these lineages are suffering, or here's how we preserve some aspect of biodiversity to hopefully inform those conservation initiatives. And then my particular project, is there a relationship between that color pattern and the body shape? So if you have a certain type of body, does that allow you to evolve different color patterns that can work with you? Or not really? Are you constrained? Do you have to be plain maybe if you're really streamlined like this guy? Ultimately, preliminary results, there's already some cool patterns coming out, right? So this is one of the fish from our data set. It's more streamlined than the rest of the fish in our data set, and it has stripes. So we did find a statistically significant correlation between stripe orientation, bar versus these stripes going this way, bars going this way, and how streamlined the fish is, right? And I tested this just in 3 fish so far. The barred ones would just be a little bit deeper body. So this was actually presented 2 days ago at the conference, so you're getting it before our landing night. But overall, I've connected to water throughout, essentially throughout my life, pretty much by choice. I keep throwing myself at these sort of water-related, marine biology-related type opportunities, and I think it's starting to actually pay off a bit. So I helped with Future Frogmen, And here's that lovely frogfish again. And essentially, the idea behind Future Frogmen is also about giving back. So I'm still rather early in career, but a lot of people really actually do want to help and help others coming up. They say you should try to be the person that you wish you could have talked to, essentially. And I think it's a pretty good rule to pay it forward. So we definitely welcome student involvement and different things like that, not just in sciences, but anything related to pottery. Right? The other big thing that has really helped me is trying to build a valuable network. So you can do this through social media even, or just people you interact with and talk to daily, or people older, younger, it really doesn't matter. But the key thing with this is that you want to follow up with them fairly often. My rule for professional stuff is 6 months. And then I keep maybe 20 or so people that I keep up with fairly often, just kind of say, hey, I'm doing this thing. And that's really instrumental to moving you forward, because if you're unsure at all, you have all these people who've done it, or who know somebody else who has done it. And that can really help you if you're feeling kind of stuck, which I personally was for a bit. And then imposter syndrome, that never goes away. That's there even no matter how high up you are in your career track. If you don't have it, great, you're way ahead of a bunch of things, but almost everybody has this on some level. And so if you ever sort of feel that I'm not really supposed to be here, or I'm at the bottom of the pool but I'm still in it, everybody definitely has that, still has to have that as a graduate student. I'm going to be a lifelong student and always admit that I don't know a bunch of things, right? So I would suggest as you go forward, hopefully you've gathered a couple tips from this today. If not, maybe you know some people you can reach out to that can